turn up the video. So yeah, we started in. Today I'm going to talk about data-driven React Native applications. So we all feeling that when we building the application, there is always need to actually counter the situation when the data is not coming and it's not working quite nice. So let's say if there's a delay, when latency and so on, we need to add some specific transitions and loading bars and so on. And I don't want to sound obvious here, but every mobile application needs data. And you know, there are many different types of data requirements you can think of. You can think about calling the backend to introduce some business logic, or just syncing the data back and forth between the mobile. No matter what kind of data requirements we have, there's usually backend being involved. And in 2016, Gartner asked the question, so what caused your mobile cross-platform project to fail? And one of the answers there was that you had unreliable backend that caused the issues. And this is what we actually are trying to do at Red Hat. We're trying to solve the problem with unreliable backends. We're trying to solve the problem for the data-driven applications, especially for cross-platform apps. So for a long time, a community, myself, we were just contributing to Cordova. Yeah, I know. And now we focusing mostly around React Native. And we using technology called GraphQL as a basis for that. So what we have been doing is that engaging with the consulting software houses through community, and you know, especially across platform. And what we've seen is that people usually have their own stack. They have their own set of the like libraries, like Angular router. They will have like very specific tools, and so on. But what's the difference between the one of the two projects is that there's always the different data requirements, different APIs. So to give you example, it's like imagine that the Tesla has this, you know, production process figured out. But now if you order a new Tesla, every time you will need to give them your own custom engine, and Tesla will need to retrofit that engine into the car. So this is how, you know, working with this custom undefined APIs look like in today. And it's kind of being challenging for most of the people we interact with. So as a solution, we using GraphQL as a core to define this strongly typed data. And we came up with this 3 levels of advancement for software houses or technologies that we can use. So first one is actually client-side GraphQL, where we build in the client side to interact with GraphQL. It doesn't need to talk with the actual GraphQL server. So before we jump into this, I want to talk a little bit about what GraphQL is. So in GraphQL, we need to define something called schema. This schema usually resides on the server, but it also affects the client because clients needs to execute some very specific queries. And everything, we call it type safe in TypeScript land because we're defining the data types straight away as form of those DSL statements. So here, for example, we see the author is being defined, and we can define operations on the author, which are named by query and mutation. So mutation is for addition, query is for fetching the changes. And on the server side, usually this is being satisfied by some, let's say, Node.js could have something called resolvers, and then we can query the data. And this data can come from REST or database and so on. Client-side GraphQL, on the other hand, it's so like I can only hear the chat. So what client-side does is that we all have resolvers and queries, both on the client side. This involves us writing the resolvers and connecting to the REST endpoints. The benefit from it is that we can work with the GraphQL, have the benefits on the GraphQL, while still don't refactor entire server-side logic. So how to do it? There are many different clients that can facilitate that. Like Apollo and GraphQL are the ones that are most popular, I think. So this is a good example where in Apollo, you can use Apollo link rest. The way it works is that what we see here, this is actual query, so it fetches the data for boards, and we annotate it by some special thing called directive, and this directive can issue the RESTful call. So once we do this RESTful call, GraphQL will contact our server, but will still interact through GraphQL client as we were working with the classical GraphQL system. Other approach has one disadvantage, that we don't control how data is formatted. So if we need to rename or introduce some improvements, every time we do inquiry, it's actually showing the request to the server. A more advanced option here is to use Apollo local resolvers, which we actually doing a lot ourselves. And this is where resolvers are clearly defined on the client side, and those resolvers can fetch from the client side. So this is where we can use those resolvers to work with our own state, but interaction with that state is being done through GraphQL queries. Another approach is to, let's say, make the RESTful calls or read and fetch from the cache. So there are clear benefits coming from it. One of those is utilizing normalized cache that is being embedded into almost every GraphQL client. For example, in Apollo, we have this Apollo store and there's normalized cache. What's the normalized cache? It's when you were building cache solution for, let's say, for example, for REST, everything that we're caching is just coming as a payload from the server. Normalized cache tries to read this payload and try to map it to actual entities. So this is what most of the mobile developers will do for native, just trying to, what comes from the server is being loaded directly to some local store to being replicated and read. Here we don't need that because we actually defining the abstraction of the data, so then we can save that directly and interacts with this store. The store itself can be refilled from the RESTful calls, subscriptions, and so on. Another benefit is something called fetch policies, and optimistic responses. So fetch policies are the way to define how the cache, normalized cache, is being used along with network requests. So for example, you can have a fetch policy that will use cache explicitly. If there is nothing in the cache, it will try to do network requests and so on. We can mitigate those fetch policies and use a couple of those. You can use queries and so on. There's mutation, which is the way to edit the data. And here for preventing this loading bar, we can use something called optimistic responses. So in a situation where we have a data requirement, and we know that the server side will return the data we already have on the client, we can provide some optimistic response, at least some partial data, let's say, for UI. So this will trigger the render with the optimistic response, and there will be re-render after original data from the server will come. So there is also update function where we can update the cache directly, and we can also refetch queries. So we can specify an array of queries that could be refetched. And there is a really good pattern in Apollo. It's called watch query. This is where Apollo client can help you to monitor your local cache. And this brings you this reactive data flow where your components could literally listen to the changes in the cache, and then you can refill the cache from other sources. This will work nicely with the local resolvers. So when you're using local resolvers, we can watch for query, and then this query could look for changes in the cache. But what will happen is that we can refill this cache through mutations, or do some pooling, or do some subscriptions. All these approaches will help us from, saving us from hammering the server. But once the information comes from the server, we can dynamically reload the view, re-render all this information. Here I'm just explaining how the cache first policy works. So basically, if there is nothing in a cache, we're trying to fetch it through network interface, and then goes through the cache and normalize it basing on the GraphQL queries. So if we have, let's say, a couple types being returned, they will be normalized to a couple different entities and saved to the cache. So yeah, it sounds nice from the beginning, but Apollo client, for example, it's not easy to be used, especially if you want to persist the cache. For example, if there is this Apollo cache persist library, and we had lots of complaint over the time where the moving from the view recreated the client, and then the cache being destroyed. So what we're trying to do at the moment is to incorporate all those patterns we have learned over the years into one client called Ofix. So this client literally extends Apollo. It doesn't rebuild anything. It just extends Apollo with the great patterns. It allows us to do offline changes. So the changes will be put on hold and then they will be resent to the server. It supports conflict resolution, and it also supports automatic cache updates and deduplication. So it's lots of different things that are coming from it. But mainly it's to make sure that we can start with the GraphQL easily and have these advanced data patterns already incorporated down there. So level number 2 is application data store. Some people call it backend for front end, but here I'm going to speak a little bit more about the client side of things. So the backend is also being generated here as a collateral, but its most important part is the client. So what we engage with consultants, and we've seen that there's a lot of repetition, both on front end and back end. And then back end could also involve a lot of effort to rebuild. And in GraphQL, this is very important because the GraphQL actually forces developer to write the queries on the client side, writes the schema, and so on and so on. So even if you do the poorly client-side approach with using local state with the GraphQL, there will be still a lot of boilerplate involved. And we wanted to help developers with building that, because what boilerplate takes us away from the writing actual business logic and satisfying our customers. So there are many different ways to resolve this problem. Examples, you can do tools, or like literally focus on some frameworks and so on. We decided to go with the tools to provide ultimate flexibility, and those tools can be extended. So if you have another use case or something, you're not forced to, let's say, create the issue and wait us to resolve it. You can just build your own flow to it. So what we're doing is that we're providing set of the tools for a very popular CLI called GraphQL CLI. So GraphQL CLI is just a command line tool that consists with many different subcommands that help you with the GraphQL development, and it's focusing mostly on source code generation. So source code generation for both client and the server. You can get the typings if you use a TypeScript and so on. So deep embedded in a GraphQL CLI is being used project called Grabbag. So Grabbag is an actual CRUD generator that helps you to reduce the boilerplate by generating the queries that CRUD specific. So what we're doing is that we're letting people to focus on their business logic. So you're starting with your entities or something that the customer gives you as like the type of the data you're dealing with, or it maybe will be the views that has some specific requirements. And then we putting it into generator that will generate the example queries the way we want it. Then we can bind this with our own stack, which it's obviously React Native plus some backend, let's say Node and so on. This will give us this fully functional server and client out of the box that can work with the data. So if you use, for example, Formic or any forms generated stuff, especially like your application doing lots of inputs, you can also generate those basing on the GraphQL schemas. And all of that comes within the Kubernetes template, so you can push it to Kubernetes or whatever, like Docker. I know it's in a kind of too much server side, but overall, it's the concept here is just to make sure that your data layer is being satisfied fully, and you're focusing only on building the right application on the client. So this is example what we generate. So like you just create the data model, and you're getting all the client queries. So this is very simple model which have just note and comment. But once we're dealing with the types that there's a 50 types overall in application. So all of those queries could be really hefty, and this saves time. Those are actually formatted using the best patterns, so you're not like if you want pagination or you want some extra stuff, you're not sacrificing the flexibility of the schema. So we use wrapper types and so on. And then the server side. And the number 3, it's the advanced state based on the generator and the client side approach, where we're trying to build the data synchronization and live updates. So if you have been using something called Prisma or AppSync, so GraphQL CLI, Grabbag, and Office are equivalent of that, but a kind of open source way. So GraphQL subscriptions are kind of easy way to get started if we have access to the server, because if the server side can actually create the subscriptions, we can get this live updates to our clients. So this introduces a lot of benefits. However, it always involves creating this backend that's being reactive and react to some events. So if we're using Grabbag, this could be generated automatically. So you have subscriptions that will be able to filter out, let's say you want to subscribe to some updates on some specific entity. And you feel free to change those patterns to wherever you want. And delta queries are concept where subscriptions are actually working only if you are on a specific view. Let's say you are open the view in React, and then you subscribe to specific events. But once you move from that view, the subscription doesn't work. So your cache is not going to get the data. Obviously, we can get the data through subscribing in a global scope, but that's not always possible because we can just move to different views and so on. So delta queries is just the ability to work on top of the pagination to give you the changes that really happen on some specific entities since you last seen them. So you can still paginate them, but the entire concept is that to minimize the amount of data you're sending back and forth from your clients. And that would be it. Thank you very much, guys. For questions, you can reach me on Twitter or directly through the website. I'm turning now the microphone so I will be able to hear it.